Today, we are buying a car, we are translating into NATO speak, we are chaining together Unary functions and calling them together, we are checking to see if a string is a valid geographical coordinate, and then we are building a breadcrumb generator. Hello world, and we are dealing with the fundamentals on today's episode of Versus Codewars. And I hope everyone is having a wonderful day today. Today's Katas will be focused on the fundamentals. And we begin today's warm-up segment with a function that checks to see if the given string, case insensitive, is a palindrome. Let's go ahead and give this a try here. Const is palindrome. We're going to have our string right here. And what we're going to do with that string, first we're going to go ahead and change that string to lowercase here. str.to lowercase. And what we're going to do with that lowercase string, we're going to use our destructuring spread trick here. We're going to have the .str inside these brackets. And what this will do is split this string into its individual characters. It's the same thing that would happen if I run this through str.split with a blank string separator here. So I'm going to go ahead and do this spread here, destructuring spread here. We're going to take that resulting array of characters and run that through the reverse method to reverse the characters therein. And we're going to join that back together with a blank string separator. Now, we're going to take that resulting string and compare it with the original str, the lowercase string. And if these two are equal, then this string is a palindrome here. Let's go ahead and punch this into Codewars to see what this looks like. And we are good on that. Our next warm-up column, we are given a length and width of a four-sided polygon. That polygon can either be a rectangle or a square. If it's a square, we return its area. Or if it's a rectangle, we return its perimeter. Alright. We're going to go ahead and give this one a try here. Const area or perimeter. And we're going to give it its length and its width. Now, we need to check to see if length and width are the same. So, if length is equal to its width. And if it is, we need to if it is, and we know that this is a square, we are going to return its area. We're going to return length times width. Otherwise, if the length and width are different, we want to return its perimeter. Now, the perimeter of a polygon is the sum of each of that polygon's sides. Now, we're dealing with a rectangle here, so we know two of the sides are going to be the same size, and the other two sides are going to be of the same sides. So we can simply do this. Return length times 2 plus width times 2. Alright, we're going to go ahead and punch this into Codewars here to see what this looks like. And we are good on that. Alright, for our next warm-up kata, we are given a string of words, and the goal is to remove all of the duplicate words from that string, leaving only the single instances of each word. Alright, let's go ahead and give this one a try. Const, let me scroll down here to get the function name, remove duplicate words. And we have our string right here. And what we're going to do with this string, we're going to split it into its individual words with the split method. Const words equals str.split using a blank string separator here. This should give us an array with the words contained in the string. Now, what we're going to do here, we're going to use something called a set. We're going to create something called a set with this array. In a JavaScript set, there can only be one instance of its elements here. So, for example, if you created a set with an array with 1, 2, 2, 3, 3, 3, that set would only contain the elements 1, 2, and 3. So what we're going to go ahead and try this. Const word set equals new set. And we are going to pass in, I think we pass in our words right here. All right, I'm going to go ahead and return that word set. And we're going to go ahead and console.log this string of the return of that function with this string passed in. Console.log remove duplicate words. And we're going to paste this string right here. Let's test this out here. Node warmup duplicate words. And as you can see, we have this set here containing only the words alpha, beta, gamma, and delta. All right, now what we can go ahead and do with that, we are going to return word set. We are going to spread the elements in this set out into its own array right here, using this destructuring spread right here. This has a lot of different applications to it, apart from just splitting strings into characters here. In this particular case, we are spreading the elements of our word set that we created up here into its own elements of a new array right here. We're going to take that array and we are going to join that together with a blank string separator. All right, running that through Node again, we get the string alpha, beta, gamma, delta. All right, let's go ahead and punch this into Codewars to see what this looks like. I'm going to hit attempt, and we are good on that. For our fourth warm-up kata, we have a scenario here. Several people are standing in a row divided into two teams. The first person goes into team number 1, the second into team number 2, the third into team number 1, and so on and so forth. Given an array of positive integers representing the weights of each people, we are to return a new array, or tuple, a pair of two integers, where the first element is the total weight of the first team, and the second is the total weight of the second team. All right, let's go ahead and give this one a try here. Const row weights. We're going to go ahead and pass in our weights array here. And what we are going to do with that is we are going to I think we'll go ahead and try using the reduce method here. Weights.reduce, and we are going to have our pair of weights and our current weight right here. And this pair of weights is going to be our accumulator, and we are going to set that accumulator initially to a tuple, a pair, where both elements are 0. Alright, and what we're going to go ahead and do, actually with this particular application of the reduce method, we are going to need the index of each element as well. So I'm going to put that in as the third argument of our predicate function here. Now, as the kata instructions say, the first person goes into team 1, the second goes into team 2, and the third goes into team 1, and so on. So we're going to want to check to see if our index is even or odd. So if index modulo 2, the remainder of index divided by 2, is equal to 0, then this is an even index here. We are going to go ahead and put that weight, add that weight into the first element of our resulting pair here. So we are going to do this. Return. This is going to set a new accumulator here. We are going to return pair of weights at index 0 plus current weight. And then pair of weights at element 1. Otherwise, we are going to add this weight to the second element of our pair here. We're going to return pair of weights at index 0, and then pair of weights at index 1 plus our current weight. Alright, let's go ahead and test this out here. Let's go down into one of these tests here and grab the array from it. How about this one right here? I'm going to hit copy. We're going to do a console.log row weights. We're going to pass in this array of integers right here. Now, according to this test here, I expect the pair of two integers, 207 and 235. Do we get it? Let's test it out here. Warm up row weights. And we do in fact get the integers 207 and 235. All right, let's go ahead and punch this into Codewars to see what this looks like right here. We are going to go ahead and hit attempt, and we are good on that. Now, our final warm-up kata is another G964 kata. Let's read out the kata instructions here. This program tests the life of an evaporator containing a gas. We know the content of the evaporator. The content is in milliliters. The percentage of foam or gas lost every day, evap per day, and the threshold in percentage beyond which the evaporator is no longer useful. All of the numbers are strictly positive. The goal of this kata is to report the nth day as an integer on which the evaporator will be out of use. Alright, let's go ahead and give this a try here. Alright, we are going to have our evaporator, and it's going to take three arguments. The content in milliliters, the evap per day, and the threshold. Now, it could probably be safely assumed that the evaporator starts out full. So we're going to go ahead and grab this right here. We're going to do a console.log. So, in this particular example, our evaporator contains 10 milliliters worth of stuff here. The percentage of that stuff lost every day, so 10%, and the percent at which the evaporator is no longer useful, which would be 5% right here. So, what we're going to go ahead and try doing is we're going to do content remaining. We're going to keep track of how much content we have left in our evaporator here. Let remaining equals content. Or rather, let remaining equal, let's call it 100 right here for 100%. And let day, we're going to set that equal to 0, and that's going to be what's returned right here. I think we're going to go ahead and try doing a while loop here. While remaining is less or greater than, rather, greater than or equal to, I think, rather, our threshold. And what we're going to go ahead and do okay, let remaining equals, let's go ahead and set that actually to our content here. We're going to do remaining minus equals evap per day. This is in percent here. Times our content. I think that's how it works here. So while remaining divided by content times 100. So while remaining divided by content times 100, that should give us the percentage right here is greater than or equal to our threshold here. Now this is going to be expressed as an integer, so I think we gotta floor this here. Math.floor. We're going to go ahead and floor that all here. And we are going to increment our day here. Alright, let's see what this looks like here. Node warmup evaporator. And that gives us 1. We do not want that here. Alright, we're setting the remaining count to our content right here. Evap per day. Okay. We need to divide this by 100 here. And we get 10. We do not want that either. I think we're going to need to rewrite this, actually. Alright, let's try this again. Let's take this from the top. Alright, we're going to keep track of how much content we have left in our evaporator. Remaining equals content. So that should initially be set to 10. We're going to go ahead and keep track of how much content explicitly in milliliters that we lose from the evaporator each day. Const evap content, we're going to call it. We're going to do evap per day times, evap per day should be 10% of our content right here. So content divided by evap per day. And then const threshold content. How much content in milliliters would be left in the evaporator at the given threshold? So with 5% of the content left in the threshold, how much content is that in milliliters? We're going to do threshold content divided by no. No. Okay, let's go ahead and take this from the top again. Alright, we're going to go ahead and keep track of the days here. And that's going to be what's returned. Okay. Now, our evaporator contains 10 milliliters of content. 10% of 10 would be 1. So we take that content and we divide that by 10. Now, the percentage of foam or gas lost every... Oh, wait a minute. Okay. Alright, what I think we need to do here, I'm going to do let remaining, the content left remaining in the evaporator. And while... Okay. Content. Alright, how do we figure out 5% of the content here? How about we take threshold, divide that by 100. So 5 divided by 100, we 0.05. So while threshold divided by 100 times content. So okay, so while remaining is greater than or equal to threshold divided by 100 times our content. And what we're going to go ahead and do inside this while loop, at the end of this while loop, we're increment our day here. Now, I'm gonna go ahead and I think this evaporates 10% of whatever is remaining here. So we're going to determine that by doing this. Now we know that the evaporator evaporates 10% of whatever is in the evaporator here. So how about we take const evap content equals remaining divided by, or rather, evap per day divided by 100. Yeah, remaining, how about we do this? Remaining minus equals evap per day divided by 100. That should give us 0.1 in this particular case, times remaining. So how about that here? And yep, we do get 29 here. So let's explain what's going on here. Here we have our function evaporator. It takes 3 parameters here: the content of the evaporator in milliliters, the however much of the current content of the evaporator is being evaporated in percentage, and the threshold beyond which the evaporator is no longer useful, also in percentage here. Here we keep track of our day here, and we increment this each iteration of our while loop, and this is what's returned at the end here. And we keep track of how much content is left in the evaporator here. Now we have a while loop here that continues as long as however much content remaining in the evaporator is greater than or equal to the original content of the evaporator times the threshold divided by 100 here. In this particular case, the threshold is 5%, so threshold divided by 100 would be 0.05 times our content here. Now, in this while loop, we subtract from our remaining here the evap per day in percentage divided by 100. In this particular case, that would be 10%, so 0.1 times the current amount remaining in the evaporator here. And we increment our day. This continues until remaining is less than our threshold content right here. And then we return our day. Alright, let's go ahead and punch this into Codewars to see what this looks like. We're going to go ahead and test that out here. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. A man has a rather old car worth $2,000, and he sees a second-hand car worth $8,000. He wants to keep his old car until he can buy the second-hand car. He thinks he can save $1,000 each month, but the prices of his old car and of the new car decrease by 1.5% each month. Furthermore, this percent of loss increases by 0.5% at the end of every 2 months. Our man finds it difficult to make all of these calculations here. This is just one example of the kata that we are going to be doing here. The goal of this kata is to find out how many months it will take our guy to save up enough money to buy the car that he wants, and how much money he will have left over here. Alright, here's an example right here. I want to call your attention to this. Now, at the end of each month, the prices of our 2 cars depreciates as our man saves up money here. And the goal is to find out how many months it will take our guy to buy this new car, and how much money he will have left over here. Alright. Now, take note that selling, buying, and saving are done normally at the end of each month. Calculations are processed at the end of each considered month, but if by chance the value of the old car is larger than the value of the new car, then there's no saving to be done here. So we can just go ahead and return the difference between the price of the old and the price of the new car to find out how much our guy will have left over here. that is the edge case here. Let's go ahead and get started here. Alright, we're going to go ahead and first handle this edge case here. If start price old is greater than or equal to start price new, and we're going to return a pair here. We shouldn't need to do any saving here, and we'll do start price old minus start price new. Alright, with that edge case handled here, we can go ahead and handle the real body of this Kata here. Alright, we're going to go ahead and keep track of the prices of our old and our new car here. Whoops. Let price new equals start price new. Let savings equals 0. We're going to start that at 0 here. We're going to do let percent loss equals percent loss by month. And then we are going to keep track of our months here. Now, we need to do this as long as while savings plus price old is less than price new. Alright, we're going to start by incrementing our month here. And then if our month modulo 2 is equal to 0, that means that our current month is an even number, which means a couple of months has passed. That means we got to go ahead and increase our percent loss by 0.5 here. Alright, now what we now need to do, we need to increment our savings by savings per month. Saving per month here. Now we need to take our price old and our price new, and we need to depreciate those by our percent loss right here. And we can do that by doing this. Price old equals, we're going to take the percentage of price old here equal to our percent loss right here. And we can do that by doing this. Price old times percent loss divided by 100 here. So if our percent loss was set to 1.5, this would turn this into 0.0015, excuse me. And we would take our price sold, multiply that by that 0.015, and then we'll take the result of that and subtract our price old by that. And we're going to repeat this with price new. Price new times percent loss divided by 100. Alright, and we are going to repeat this until our savings plus the current price of our old car is greater than or equal to our price new. And once we reach the end of this while loop here, we're going to go ahead and calculate how much money we have left here. Actually, we're going to go ahead and console.log that just to see what this looks like here. Console.log month savings price old price new and percent loss. Alright, we're gonna go ahead and test this out here. Node buying a car. Yeah, that looks hopefully right here. Alright, we're going to go ahead and find out how much money we now have left over here. Const available. And we're going to do savings plus price old minus price new. And we are going to console.log that. And that gives us 766. And that is actually what we want to see here. So, what we are going to go ahead and do now, we are going to return a pair here. The first element is the number of months that we needed to save up for our new car here. And then our second element is going to be how much we have left over after selling the old car and then buying the new car with the money that we have accumulated here. Get rid of this bracket here. I don't know how to end up there. And we need to floor this here. So we're going to do math.floor available right here. Alright, we're going to go ahead and console.log that, and we get the pair 6 months and $766 left over. Alright, let's go ahead and pull from another test here. How about this one here? Copy. I'm going to do console.log. I'm going to paste that call here. And we should get 0 and 4,000 there, and we do. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And I run these tests here. And, uh-oh, we got a problem here. What's going on here? Okay, we actually need to round that to the nearest integer here. Floor isn't going to work here, so we'll do math.round instead. Let's try that. And we are good. Not really much to say about this one. However, I could have made this Kata solution the slightest bit more performant by keeping track of the decimal form of our percent loss at the start and every time that percent loss changed at the end of every couple of months in our while loop here. That way I wouldn't need to calculate the percent loss divided by 100 every time I would depreciate the price of the new and the old cars. This is the International Radiotelophony Spelling Alphabet, also known as the NATO Phonetic Alphabet. As you can see here, each letter here is mapped to a special word starting with that letter. A for Alpha, B for Bravo, C for Charlie, and so on, as you can see in this object here. The goal of this kata is to translate a string to this phonetic alphabet here. Like for this example here, if you can read, we are supposed to return India Foxtrot, Yankee, Oscar, Uniform, Charlie, Alpha, November, Romeo, Echo, Alpha, Delta. I better go ahead and change this here. Alright. Now, this dictionary you see here, this object is preloaded into the Kata solution here. I just have it pasted right here for the sake of this video here. Now, the set of punctuation used here are commas, periods, exclamation points, and question marks, and they should be kept in our return string. Spaces, however, should not. Alright, let's go ahead and give this a try here. Every word and punctuation mark should be separated by space, and there should be no trailing white space. Alright, let's go ahead and give this a try here. Const to NATO. And we're going to have our words here. We're going to have our string here. Alright, what we're going to go ahead and do, we need to be able to preserve our punctuations here. Alright, first we need to go ahead and trim our string here. And then what we need to do, we are going to take the string, split it into its individual characters, and we are going to run that through the reduce method here. And we are going to have our result string and our char here. And our result string accumulator is going to be initially set to a blank string. And what we are going to do, what we need to do is we need to take, we're going to return our result plus. Now. Okay, what we'll do, if char, if NATO and char is defined in our object here, what we'll do is we're going to return results. Oh, this is going to need to be an array, actually. Gotcha. This is going to need to be an array, actually. So, results. Okay, we're probably going to need to keep track of our punctuations here as well. So what we're going to do, we're going to do a punctuations. We're going to have our comma, period, exclamation point, and question mark here. Anyway, and if this char is included in our NATO dictionary here, we're going to return the contents of our result array thus far and the NATO and char here. Else if punctuations dot includes our char here, we are going to return that result array spread out and our char here. Then else we're just going to return a result array here. Now we're going to need to take that resulting array and join that together with a blank a space separator here. Alright, let's go ahead and test this out here. Console.log to NATO if, comma, you can read, exclamation point. Let's test this out here. Node read this. Foxtrot, Yankee, Oscar, Uniform, Charlie, Alpha, November, Romeo, Echo, Alpha, Delta. That looks right. Let's go ahead and punch this into Codewars to see what this looks like here. And we don't need to include the object here because that's already preloaded in the Kata solution here. Let's run the tests here. And we've got a problem. What's going on? Oh, wait a minute. Did we include the I here? Yeah, we did. Oh, wait a minute. We need to convert our string to lowercase here. Yeah, there we go. I think what happened was we forgot to convert our string to lowercase. And that's where we were going wrong. Let's hit the test here. And we are good. Not really much to say about this one either, but another way I could have implemented this Kata solution was to do the following. Take the characters from our split string and run that through the filter method to filter out any white space from that array, and then take that resulting array and run that through the map method, mapping each character to its entry in the NATO phonetic table, or that character itself if that character is not present in the table. And then join that resulting array back together with a space separator. Given an array of unary functions, the goal of this kata is to write a higher order function for chaining together this list of unary functions. In other words, it should return a function that does a left fold of the given functions here. Functions like these right here. This first one takes a number as a parameter and returns that number times 2. This second one here takes another number as a parameter and returns that number plus 2. This third one here takes a number as a parameter and returns that number raised to the power of 2. Now I'll call your attention to this call right here to our chained Kata solution here. This Kata solution takes an array of our 3 functions up here in this order right here, f1, f2, and then f3. And then the higher order function returned by this Kata solution will be called, passing in 2 right here. What this is supposed to do is to call these unary functions left to right, right here. So we call our f1 right here first. That'll take our 2 and multiply it by 2, and that should give us 4. Our f2 is called next with the return of f1 as the parameter here. And that should take our 4 and add 2 to it, so we get 6. We take that 6, and then we call f3, passing in that 6. That takes that 6 and raises it to the power of 2, and that gives us our return value here of 36. Alright, let's go ahead and give this a try here. Alright, what we'll need to do, we need to return a function here. So we're going to go ahead and return our single value here. Alright, we are going to go ahead and we're going to return this value at the end here. And then we are going to do for const func of functions. We're going to do val equals func. We're going to call our func and we're going to pass in our value here. And that should be all we need to do here. Let's go ahead and test this out here. Node Unary. And that should give us 36. Alright, let's go ahead and pull some more functions from our tests here. Alright. Here we have our functions f4, f5, and f6. Alright, f4 takes a string as a parameter here. Alright. F4 takes that string, splits it into its individual characters with a blank string separator, calls concat on it for whatever reason. Anyway, it calls reverses our characters, joins it back together with the blank string separator, and then splits it again with a space separator here. Our F5 here takes, I think it's a string array right here, and then reverses it. And then F6 here takes a string array here, I think here, and joins it together with an underscore separator here. Alright, let's go ahead and grab this right here. It's going to be another call to our chain function here, our Kata solution here, using our F4, F5, and F6. And it takes this string here that says lorem ipsum. And I expect to see this string return right here. Merolmupsi. Separated by an underscore here. Let's try it. Node Unary. And yep, we do see that string right here. I just want to see some here. What would happen if we got rid of this call to concat here? And we do get the same result right here. Yeah, I don't understand what that concat call was doing there with no arguments here. The concat method takes the array on which it's being called and adds to the end of it the array that is passed in to the call to that method here. For whatever reason, this was being called with no arguments, and I don't know why. I could use a little insight into that. If you have any explanation for that, feel free to drop one in the comment section below. Anyway, let's go ahead and feed this into Codewars to see what this looks like here. We're going to run our tests here. And we are good. Not really much to say about the Kata solution itself here, but another way I could have implemented this Kata solution was to do the following. Take the functions here And in the higher order function return here, run those functions through the reduce method and set the accumulator according to the return value of each of the functions in our unary function array. And then the return of the reduce method will be the return value of that higher order function. Given a string, the goal of this kata is to validate if that string represents a valid geographical coordinates. Valid coordinates will look like the following here. I will call your attention to this bolded string right here, containing two floats. The first one being a latitude and the second a longitude. Alright, the return value here should either be true or false. It will return true if this is a valid geographical coordinate, the string passed in. Latitude, which is the first float, can be between -90 and +90. Longitude, which is the second float, can be between -180 and +180. Coordinates can only contain digits or one of the following symbols, including the space after the comma. Alright. Let's go ahead and give this a try here. Alright. We are going to be using regular expressions for this one here, so we needed to create a couple here. First, our latitude regex. And I think that is going to be dash, the optional dash. I think for this first one here, one to 9, that's optional here, and then 0 to 9 here. And then everything after that should be optional here. We'll have our dot. And I think anything from 0 to 9 afterwards there. Well, actually, this is going to need to be a big old regex here because we also need to account for the comma and space here as well. So, const chord regex. We're going to have our caret and $sign to indicate the start and end of our strings here. First, we'll start with the latitude. And we'll have the optional dash here to look for the minus. An optional... Actually, yeah, okay. We'll have our first digit, our 0 through 9 here, and then our 0 through 9 here to indicate our second digit right here. Now, what we need is the comma and the space. And then we need to look for our longitude right here. We'll have our dash, our optional dash here again. And we'll have one of two values here. And that's going to be either a 1. It's either going to be a 0 through 9 and a 0 through 9. I think we can do a 1, 2 here range here. Yeah. We'll have either that or We'll have a 1 here. A 0 through 8. 0 through 7 here. And then a 0 through 9 here. That should handle any cases between 100 through 179. Or we'll have here 180 here. So what I am hoping to achieve with this regular expression here, we actually need to handle the dots here as well. Dot. I'm going to go ahead and copy that little bit over here. Alright, so what I'm hoping to accomplish with this regular expression here. First, this will handle the latitude here. It'll pick up the optional dash in case it is a negative number, a negative float. Then we'll look for 1 or 2 instances of the numbers 0 through 9 here. That's going to be the left hand of our latitude before the period here. Now, if this is a decimal here, this will also look for the period plus any number of instances of 0 through 9 right here. And this capture group will be optional here. Then we look for the comma and the space here. And then we look for our longitude right here. Again, we'll have this dash right here, optional here in case it's a positive or a negative here. And we'll be looking for any one of 3 cases here in this capture group right here. First, we'll want to look for any instance of a 0 through 9 right here. 1 or 2 instances of the 0 through 9 right here. Or if this picks up a 1, or if this picks up 3 digits right here, we want to look for the 1. The second digit will be any instance between 0 and 7, and the third digit, any instance between 0 and 9. This should handle cases of between 100 and 179. Or we'll look for our 180 right here. I think I might need to reverse that here. I don't know yet. Anyway, after this, just like we do with our latitude here, we are going to check to see if the dot and any additional digits are present for our decimal here. And this will be optional here. And this will be the end of the string right here. Let's go ahead and test this out and see if this passes muster here. Let's go ahead and take our string here. I'm going to take the string here. I'm going to copy it. Console.log is valid coordinates. We're going to pass this in right here. Alright, we're going to go ahead and return chord regex.test. This will test the given string against this regular expression and return true if it passes. We're going to pass in our chords here. Alright, I hope I got this right. I'm not exactly an aficionado when it comes to regular expressions. I could use a little work on that. Node chord validate. Oops. And this does return true. That's a hopeful sign. Let's go ahead and test out all of these valid coordinates right here. I'm gonna run this here. You know what? I have a better idea. I will be right back. I'm going to go ahead and make arrays of all of these tests right here. Be right back. Alright, now I got all of these strings I can go ahead and test against here. And I've got them in 2 different arrays here. The strings in this array should return true with our Kata solution here. And the strings here should return false with our Kata solution. Let's go ahead and test these out here. Alright. As you can see, all 5 of these return true. However, it looks like one of the strings in our false array is returning true as well, and we do not want to see that. What's going on here? Alright, I'm finding symbols. Alright, looks like the string 99.234, that would be why. Oh, okay. Yeah, we do need to update our regex a little bit here. So I'm going to go ahead and... Alright, I'm going to go ahead and encapsulate this in a capture group here. And we actually need to look for one of two different cases here. Either the 90 or the 1 or 2 instances of our 0 through 9. Let's try that. And it's still returning true. Alright, okay. What we'll need to do then. Our first digit here should be a 0 through 8 then. And then the other one should be a 0 through 9. Alright, this should work here. And now one of our true ones is returning false. Because this should be optional here. True, 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 true. False, false. Yep, I think this is going to do. Let's go ahead and punch this into Codewars to see what this looks like here. Let's go ahead and hit attempt. And we are good. Whenever you are working with regular expressions with capture groups, if you do not necessarily care about what's being captured by that capture group, what you can do is begin that capture group with a question mark and a colon. That turns the capture group into what is called a non-capturing group. And whatever is captured in that group is omitted from your operations if you were doing something like .match or .exec. And doing so with all your capture groups might add a little bit of extra performance if you were just using the test method like we did in our Kata solution. This is a breadcrumb menu. This graphical control element is often used to help users navigate through things like pages on a website, or in this case, folders in a file explorer like KDE's Dolphin, as you see here. We are going to be implementing something like this in this Kata solution here. Let's read through this here. I will be linking the Wikipedia article on breadcrumb menus in the description below. For this kata, our goal is to create a function that takes a URL, strips the first part of it out, labeling it always home, and then builds out a breadcrumb menu, making each element but the last anchor element linking to the relevant path. The last one has to be a span element, getting the active class. All elements need to be turned into uppercase and separated by a separator, given as the second parameter of this Kata solution. The final element can terminate in some common extension like .html, .htm, .php, or .asp. If the name of the last element is index.something, you can treat it as if it was not there, sending users automatically to the upper level folder. Here are a few examples which I will call your attention to right here. Here we have these URLs right here, and our second parameter here is the separators that we will be using for our breadcrumb menus. And here's what the solutions ought to look like right here. Note that the first element of our breadcrumb is always the home right here. And then we will build out our breadcrumb menus as proper right here. Here we have links to our pictures and our users for our first and second ones respectively. And then it always ends with the span with the class set active here with the final breadcrumb in our breadcrumb chain here. Alright, and note that each element of our breadcrumbs are separated by the character that we provide in the argument's second argument right here. Here is the catch, however. If we have an element or elements that are longer than, if we have an element that is longer than 30 characters, we have to acronymize it, shorten it turning it into an acronym, taking just the initials of every word. And each of the URLs will always be given in kebab case, lowercase kebab case right here. And when we are acronymizing very long elements here, we have to ignore the words in this following array right here. I will go ahead and copy that into the Kata solution when we get started. A URL composed of more than 30 words separated by a dash and equal or less than 30 characters long needs to just be uppercased with hyphens and replaced by spaces. Alright, now we have to ignore anchors and URL parameters if present here. Let's go ahead and have a look at a couple of examples with very long URL pieces here. Alright, as you can see here, this is acronymized and uppercased right here. Alright, now we will always be provided with valid URLs to web pages in common formats, so we shouldn't need to validate them at all here. Alright, with all that being said, let's go ahead and get started right here. I'm going to go ahead and hit train. And we are going to do this. Const generate BC, generate breadcrumb. We are going to be given our URL and our separator. And what we are going to be doing here. Now let's handle an edge case here. In the event that, alright, first we need to go ahead and strip out anything after any instance of a pound sign or question mark sign to indicate the start of an anchor or a URL parameter here. And what we can go ahead and try doing here, we'll do URL equals URL.replace either the question mark or the anchor. Oops. Yeah, either the question mark or the anchor here. Yeah, let's go ahead and place that in its own group here. And anything after that with a blank string here. Alright, let's go ahead and console.log that to see what that looks like here. And we're going to do console.log generate BC. We're going to pass in, I'm going to grab this here. And we're just going to go ahead and see what that looks like at first. Node breadcrumb generator. And that should strip out anything after this question mark or the anchor or the pound sign anchor here. And that should leave us with just our URL here. Alright, with that all said and done, let's go ahead and split this URL into its individual pieces here. We're going to do const parts equals URL.split. And we are going to use as a separator the / here. And we're going to go ahead and console.log that here to see what that looks like here. And we are going to go ahead and grab this right here. We're going to go ahead and copy that and paste this here. That should give us an array containing the parts of our URL. Now, what we need to do, here we can go ahead and handle our first edge case here. If parts dot length is equal to 1. We can just go ahead and return a span class active active, and I think that would say home. Right here. Let's go ahead and test that out here. And that will give us our span class active home right here. Otherwise, what we need to do, we'll need to keep an array of all the elements of our breadcrumb here. And what we'll go ahead and do, const crumbs, and we are going to set that to an array, and that first element of our array is always going to be our anchor here, our home anchor right here. A ref home right here. Now, with that being said, we are going to be returning these crumbs joined together with our separator that we passed in as the second argument of our Kata solution right here. Alright, let's go ahead and get this back here. Alright, listen, and let's go ahead and get started with this right here. Alright, we're going to go ahead and iterate for that I equals 1, because we want to start with the second part right here, because we've already accounted for the first one. I is less than crumbs.length plus I. And we are going to index the crumb at the current index here. Const crumb, or rather, yeah, const crumb equals crumb, or rather, no, we need to index our parts here. We're going to do const part equals parts at I. And what we are going to do here, alright, we are going to go ahead and grab this array right here. And we're going to go ahead and copy paste that right at the start of our Kata solution here. Const ignore these. And these are the words we need to ignore when acronymizing the very long parts of our URL. Now, what we are going to need to do now here. If the part is very long, if part.length is longer than 30, and we'll do an else case right here. Now it says here, if we have one last extra rule, if one element other than the root or home is longer than 30 characters, we have to shorten it, acronymizing it. Taking just the initials of every word, URL will be always given in the format, this is an element of the URL, lowercase hyphenated, You should ignore words in this array while chronomizing. This is the array we just copied up here. A URL composed of more words separated by a dash and equal or less than 30 characters long. Needs to just be uppercased with hyphens and replaced by spaces. Let's have a look at these examples here again. Alright. I think what we need to do Alright. I think we'll do crumbs dot push. We'll do a template string here. Or rather, if I plus 1 is equal to parts.length. And we'll have an else case right here. Crumbs.push. We'll have a template string here. A ref. We'll have a slash. We'll have a placeholder here with our part. And another slash right here. And we'll have another placeholder right here. Let's set it to an empty string right now so it doesn't yell at us here. Now, if we are dealing with hyphenated separated strings that are equal to or less than 30 characters long, okay, alright, let's have a look at some of the other examples up here. Okay, I think I know just what we need to do here. Alright, I'm gonna go ahead and do crumbs.push span class active. Alright. Alright, alright, we're gonna go ahead and keep track of our crumb here. If part.length is greater than 30, whoops, then what we need to do with the part, we need to split it into its individual characters. Part.split. We need to split that part into its individual words using a hyphen separator here. And then we need to filter out any word in that part that's included in this array right here. We're going to do filter. word. Ignore these dot includes word. So what this should do, this should filter out any word in our separated part here that is included in this ignore these array up here. Now what we need to do with those resulting words, we need to run it through the reduce method here. And we'll have our accumulator here and our character here, our word here. We're going to add that word, the first character of that word, uppercased. And we're going to set that initial accumulator to a blank string right here. And then what we should be able to do, actually go ahead and be able to assign this to our crumb here. Should be able to join that together with a blank string separator here. Now, otherwise, a URL composed of more words separated by a hyphen and equal or less than 30 characters in length needs to just be uppercased with hyphens replaced by spaces. So, what we'll go ahead and do, we're going to do crumb equals part dot replace. We're going to replace any instance of that dash. And we're going to use a regular expression to replace all instances of that dash with a space. And then we're going to change that to uppercase here. Alright, that should work. Let's go ahead and place that crumb in the second placeholder of our string here. And I hope that works. Let's go ahead and test this out here. And we do need to pass in that separator here. Let's go ahead and do that here. We have our home, we have our pictures, and we have our holidays on HTML. We do need to terminate that extension here. And I think we can go ahead and do that. I think we'll do crumb dot split dot and element 0 here. We also need to do this if the index at the part of this part's array at the next index starts with index. I think, what version of Node are we using with this? 8.1.3? Okay, what we need to do in our else case right here, we need to go ahead and get the part index at the next index here. Next part equals parts at I plus 1. And then if next part dot split with the dot separator at index 0 is equal to index, then what we need to do crumbs dot push span class active, and then our crumb here. And then that index can be expected to be that last part of our URL. So we can just go ahead and break out of the loop here. All right, we have our home, we have our pictures, and we have our holidays here. Now let's go ahead and test out our index.html here. About this one here. I'm gonna hit copy. I'll go ahead and hit paste here. We have our home and our docs here. And that is what we want to see here. How about the Codewars profile of one GiacomoSorbi, who is the author of this Kata here. Alright, I'm going to copy that and paste that in here. And we get our home, users, and GiacomoSorbi, all one word and capitalized. And that is what we want to see here. Now let's handle these very large edge cases right here. I'm going to copy this. I'm going to copy this over here. Very long URL to make a silly yet meaningful example here. Should be acronymized. And we have an error. Join is not a function. We do not need this here. Because this call to reduce is returning a string. Alright, let's go ahead and review that here. We have our home. We have our very long URL to make a silly yet meaningful example here in our anchor here. And we have our acronymized form here, VLUMSYME. And that is what we want to see here. Like where this is going. Alright, let's go ahead and copy this final example over here. Let's go ahead and copy that over here. And what does this look like here? Alright, we have our home here. We have our users here. And we have the name GiacomoSorbi. Hyphenated here. That hyphen is replaced with a space and that name is capitalized right here. And that is what we want to see as well. Now let's handle one more edge case, the anchors and the URL parameters. We should not be seeing that in our return string here. And we do not see that here. How about this URL parameter here? And we do not see the URL parameter either. Alright, I think I like where this is going. Let's go ahead and console.log, comment out this console.log up here. And let's go ahead and try punching this into Codewars to see what this looks like. Let's hit test. And we have a problem. What is going on here? Ooh. These HTML entities is going to make this really tough to read. I think we got Okay, let's go ahead and uncomment this console.log here and see where we're going wrong. Docs. Alright, we have Microsoft.com. That's our home. We have our important. We have our okay, and let's have a look at some of these examples down here. Let's run test here. Alright, let's have a look at the instructions again. Okay, let's actually go ahead and console.log that URL here. I'm gonna do console.log URL just to make that readable. Alright, I'm gonna go ahead and grab this here. We're gonna copy that and paste that into the local solution here. Whoops. I'm gonna do another console.log. And we're gonna go ahead and see what that looks like here. Oops, yeah, I kind of need to call our function here with these two parameters. Oops, come on. Alright, there we go. Alright, we have our home, we have our important, and I think I see where we're going wrong here. The confidential folder is supposed to be inside of our important here. So let's I have an idea here. We're going to go ahead and keep track of a combined part here. And we're going to do we're going to make this a let here. And if I is greater than 1, we're going to do an if else here. Do part if I is 1 here. Alright, if our I is equal to 1 here, what we'll go ahead and do, we're going to go ahead and set our part equal to the part at this index right here. Otherwise, what we need to do, yeah, we actually do, I'm actually going to go ahead and undo all of that here. Alright, now, if our I is greater than our I is set to 1, we can go ahead and set our combined part equal to just our part right here. And then otherwise, we can do combined part equals, whoops, equals combined part plus forward slash plus our part here. And then what we should be able to do from here, we'll put in our combined part right here. Let's see what that looks like here. Important, confidential. That should work here. Let's go ahead and punch this into Codewars to see what this looks like here. Oops. Hit copy, paste. Let's try this one out for size. Those test passes. And now we've got to handle the random tests here. Alright, let's go ahead and bring back that console.log URL here. And let's hit attempt. Just to see where we're going wrong here.
Home.
Oh. Okay. Or if the last character of our string is the, Alright, what we'll do, if URL at URL.length -1 is equal to the slash. Let's go ahead and punch that in here. And hit attempt. Again, we gotta do the console.log. I'm gonna go ahead and do that up here in the Katas, our local solution here. Console.log URL. We'll go ahead and copy that over to our Kata solution here. I can see we're dealing with some random tests here too. And we have our I'm going to go ahead and expand out the size of this window here, just so we can see this fully here.
Oh. Oh, that's interesting. Let's go ahead and run through some more of a failed test here.
Oh, wait a minute. All right, we need to account for the protocol here, string here as well. All right, what we'll go ahead and do, we're gonna run another replace call here. We need to replace the HTTP protocol at the start here. HTTPS. Alright, let's go ahead and put an HTTPS at the start here. I think that'll help here. What I'm doing here is debugging some of the failed tests that we're getting here. And that seems to have taken care of all but one of our failed tests here. Oh, the one failed test we need to handle here now has actually passed. So now we need to deal with this one here. Okay, and this looks like another edge case here. So what I think we'll go ahead and do here, I'm going to do this in a separate if statement here, just for the sake of readability here. If parts.length is equal to 2, and parts at index 1 split with a dot separator is equal to, dot 2 lowercase is equal to index, we'll go ahead and do just the same thing we did up here. Alright. Now let's go ahead and punch that into Codewars to see what this looks like. We'll run our normal tests here. And what now? 2 lowercase is not a function. Because we need to index n 0 here. Let's go ahead and reflect that in the Kata solution here. Let's find that here at index 0. And we are good. Wait a minute. I'll go ahead and verify that here. And we are, yep, all of our tests have passed and we are good. Now that was quite the heavy lift and a head scratcher to get done, and it took me quite a bit of time for me to get this one done, but I'm glad I got this one done, and I had a lot of fun doing this one too. Let me know what you think about this Kata solution and my other Kata solutions in the comments section below. I would really love your insights. And that will do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and would like to share your authored katas with me, drop links to those katas in the comments section below, and you might see me tackle some of those katas in a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.